Welcome back, everybody. In the last video, we started the multiplication rule, but we only did what we called independent events. But not all events are independent. So now we're going to explore the idea of two dependent events, and that means that event 1 affects the probability of event 2. All right, so let's just jump in. Here's the formula, but let's just jump into some examples. I think you'll start getting the hang of it pretty quick. All right. In a shipment of 25 ovens, 2 are defective. If 2 ovens are randomly selected and tested, find the probability that both are defective. Note that this is without replacement. Now, this without replacement is the key word. So, for example, if we test oven number 1, we've tested 25 ovens, right? So the probability of number 1 being defective is 2 out of 25, right? And the idea that it's dependent, we still multiply, but then if the first one is defective, right, because we want the probability that both are defective, we only have 1 defective oven left out of a total of 24 ovens that remain. So at this point, we multiply these 2 together, right? You note the slight difference. We have 2 over 600 or 1 over 300. All right, so the idea is that once we test an oven, we remove it from testing again. All right. So let's take a look at a few more. We can extend the multiplication rule to 3 or more events. And I like cards from a deck. They're always appropriate. So 3 cards are drawn from an ordinary deck of cards without replacement. Again, without replacement tells me they are dependent events. Find the probability of getting 3 jacks. All right. Well, how many jacks are in a deck? There are 4 jacks in a deck out of a total of 52 cards. So let's say I draw a jack. Then how many jacks are left? Well, I didn't replace it, so there's only 3 jacks left out of 51 cards. Then only 2 jacks left out of 50 cards. All right, so why don't you guys pause the video and do a little multiplication, and we'll get the answer on the back end. All right, hopefully you got an answer. I was able to do a little bit of simplifying beforehand. So the 2 and the 50 go to 1 out of 25. The 3 and the 51, it's 1 over 17. And the 4 and the 52 is 1 over 13. So that would equal, right, 13 times 17 times 25, 1 times 1 times 1. I got 1 over 5525. And that's the probability of drawing 3 straight jacks out of a deck of cards. All right, so again, we're drawing 3 cards without replacement. Now the question is probability of getting an ace, a king, and a queen. Note the and. The and tells me that we're doing multiplication rule, and the fact that it's without replacement tells me it is dependent events. So how many aces are there? Well, there's 4 out of 52, and a king. So there's still, right, if I drew an ace, there's still 4 kings in the deck, but now I have out of 51. And there are still 4 queens in my deck, but now I only have 50 cards left. All right, so why don't you guys take a moment, pause the video, and try to multiply out, and we'll get the answer on the back end. All right, so hopefully you got 4 times 4 times 4 is 64. 52 times 51 times 50, I got 132,600. And we can simplify that to 8 over 16,575. And you're always welcome to simplify before you multiply. For example, the 4 out of 52 can be simplified. The 4 over 50 can be simplified. So by all means, do that to lower your burden. All right. So let's take a look. The probability of a club, a spade, and a heart. All right. Well, now we're looking at the deck from a different perspective. There are 13 clubs out of a total of 52 cards. Now I'm going to multiply that. Right? If I draw a club, then I want to draw a spade and a heart. Yes? So, sorry about that. So a club, 13 out of 52. Then we draw that club. So there are 13 spades, but we only have 51 cards in the deck now. And then after we draw that one, we still have 13 hearts, but only 50 cards. All right. So why don't you pause the video, do some multiplication, and we'll talk about the answer on the back end. All right, hopefully you did your multiplication. I wound up with 2,197 over 132,600. And that simplifies to 169 over 10,200. Again, you can always simplify before you multiply. 13 out of 52 turns out to be 1 over 4. Now the probability of 3 clubs, well, if there's 13 clubs in a deck out of a total of 52 cards, and then after we draw that club, there's only 12 clubs left in that deck, and there's only 51 cards, and then we draw that, right? So then we have 11 clubs left out of 50 cards. So again, the bottom is going to be the same, 132,600 as the last two. The numerator I got to be 1,716, and that simplifies to 11 over 850. All right, so that is the multiplication rule with dependent events. I hope you enjoyed the video. Next video will be on the next section, conditional probability. Hope to see you then.